Hello friends, today we are going to learn two-dimensional NMR spectroscopy. In that, first we will see Cauchy spectrum. From Cauchy spectrum, one can know which hydrogens are coupled to each other. Means it gives information about proton-proton coupling. Conventional H1 NMR spectrum has frequency axis and an intensity axis. But in case of two-dimensional NMR spectroscopy, spectrum has two frequency axes and one intensity axis. In short, H1 shift correlation spectra in which both frequency axes shows H1 chemical shift. Thus, it is called H1 shift correlated spectroscopy. In short, Cauchy spectra. Cauchy spectrum looks like mountain range if viewed from top. However, a counter plot is used to identify the compound where slices of each mountain are represented by a counter circle rather than stack plot. From reference point, one can start analysis of the compound. So, here in Cauchy spectroscopy, H1 NMR spectrum run both along x and y axis. Signals are repeated again as a spot on the diagonal. Here the diagonal spots are important. Diagonal runs from upper right corner to lower left corner. And the coupled protons can be identified by using off-diagonal peaks. For that, you have to draw two perpendicular lines from a cross peak. Then the peaks on the diagonal, those are intersected by these two lines, are said to be coupled to each other. So, let us start to understand the Cauchy spectroscopy by using an example. Here, we are going to take an example of meta-dinitrobenzene. Some tricks, I have provided some tricks here to assign the structure. First, find easily assigned downfield protons. Then, find number of types of protons. Then, show splitting of signals. Strength of signal peaks indicates the number of equivalent protons. These are some tricks. By using this, you can assign structure to the spectrum. In this example, H2 protons are most downfield protons. These H2 protons are most downfield protons, hence easily assigned. Horizontal line from H2 spot and vertical line from spot at 8.6 delta intersects at off diagonal spot, confirming their coupling. So here we can say H2 protons are coupled with H46 proton. Similarly, signal from H6 and H4 is connected by a cross peak to the signals from H5, showing coupling between H46 and H5 proton. H2 proton can't be connected to H5 since there is no off diagonal peak relation. Thank you very much.